Alright, so I wanted to give you a quick week 5 lab quiz 5 review. So remember spirometry is a test that basically tests pulmonary function, right? There's a pulmonary function test. And so typically in order to get accurate results, right, your patient should be sitting and they should be relaxed. We have a lot of different, lung volumes and lung capacities that we've already talked about, such as like those respiratory volumes, right? Those lung volumes, like the tidal volume is just simply the 500 mils, right? That you breathe in and out under normal conditions. You have the inspiratory reserve volume, right? That's the amount of air that you can forcefully inhale after a normal, inspiration. Of course, the opposite is the expiratory reserve volume, is the amount of air that you can forcefully exhale, push out after a normal expiration. And then we have the residual volume, right? The residual volume is going to be around 1200 mils. 1200 mils, I'm sorry, let me erase this. Oh, well, nonetheless, 1200 mils equals 1.2 liters. That's why you see it right there. So that residual value, this is going to be the amount of air that's remaining in the lung after a forced expiration. This is going to be the amount of air that's in the lung that you just simply can't push out, right? And so we can't measure the residual volume using a BioPAC spirometer. So remember, you can't measure that residual volume using a BioPAC spirometer. But again, that residual value typically is going to be, right, it should be 1.2 liters, right, or 1200 mils of air. Okay. Now, the diaphragm and the other accessory muscles, they're going to help with inspiration and expiration, right? So we have, when we want to breathe in, we are going to contract our diaphragm and our external intercostal muscles, right? Contracting these, your diaphragm will go down, your intercostals will expand your chest. Both of these will lead to an increase in thoracic volume. Thus, if you increase volume, you decrease pressure. And so air will move down its pressure gradient into your lungs, right? Now, we do have our respiration. It's going to be controlled by our medulla and our pons, right? So part of your brainstem, your medulla oblongata and your pons are going to have those respiratory centers in there. That's going to be able to control rhythmic breathing, right? The forcefulness of your breathing, right? Your respiration rate, things like that. And remember, it's those pleural cavities, right? Your lungs are within a pleural cavity. And so we have this pleural, visceral pleural, parietal pleural, right? They're going to line your lungs, okay? And so that in between the visceral pleural and the parietal pleural is going to be that pleural fluid. And that pleural fluid basically acts as a glue. It holds your lungs to your chest wall. So basically your lungs won't collapse. So your lungs initially just simply want to collapse. Your chest wall wants to expand. So in order to not have this happening, we have that pleural fluid, which acts as a glue. Now, if there was an opening in your chest cavity, such as a puncture wound, right? So if I put a knife through right there, that breaks that cavity, right? It breaks that pleural space, which acts as a vacuum. And if you destroy that vacuum, right, those lungs will deflate, right? You also want to have some matching terms, right? But before we get there, right, the internal conditions in which air tends to flow into the lungs, it results in an increase in the thoracic volume and a decrease in pressure. So remember, I mentioned that the contraction of your diaphragm and your external intercostal muscles, they allow for the expansion of your thoracic volume. But as we remember, right, those respiratory laws, right, as you increase the volume, you decrease pressure and vice versa. But if we have decreased pressure in our lungs, remember, air, right, wants to go down its pressure gradient. So it's going to go from an area of high pressure to an area of low pressure. And that's why you're able to inhale, right? That's why air will forcefully rush into your lungs, because you increase the volume and you decrease the pressure. Okay? Also remember these matching terms, right? I won't go through all of them, right? Just remember them, okay? You can go over them, write them out if you need. When we're looking at respiratory sounds, so as air flows in and out of the bronchial tree, it's going to produce two characteristic sounds that can be auscultated with a stethoscope, right? So we have the bronchial sounds, right? This is going to be produced by air rushing through the large respiratory passageways, such as the trachea and the bronchi. This is going to be heard both during inspiration and expiration. We have the second type of sound, which is going to be that vesicular breathing sound, right? That's apparently is going to result from air filling the alveolar sacs, and that's going to resemble the sound of like rustling leaves. This sound is going to be heard best in the lung area, okay? That was your lab quiz review. Happy studies for week 5.